putting stuff into your brain.
Up lately.
Well, I have more stuff coming out than I have going in, so I must have room for more. Anyway, so we're gonna try to hempstudy.org. I found one way to get that certified. If you haven't had a chance to look at that, I would encourage you to do so. It will be a big help for you.
Mike and the Mike keys are on. What's your current status? Do you have
Right
anything?
behind you there. I'm gonna hit this other one.
Here, no emergency needs, and
There we go.
I am actually able to help.
And that way we can kind of see that a little bit better.
Oh, thanks, sir. Appreciate that.
All right, we're just going to kind of quickly run through some of these slides we started with last weweek in Module 2, because we're going to finish off Module 2 tonight. But I want to just kind of hit on these. And before I do that, does anybody have any questions? Questions?
Had a double there, but I was able to get Bruce keys.
Any
WL. What's your current
questions?
status? Do you have any emergency needs?
I like it. Well, we got it. I know Brian had some questions as he came in, and he had some good questions.
Thank you, sir.
And
Appreciate
it's a good question for everybody.
Any more checking?
So last week I had two handhelds. Remember that? Two handy talkies, what we call them. And that handy talkie, I can hit the repeater. That's the same repeater that Lee's out there doing the net on right now. So we're hitting that repeater out there in Avon.
Brett, can you try again? I got part of it. Keys are on.
It's up a lot higher, and it has a big footprint, and my handy talkie can hit that very easy. But what if I have another friend? What if Brian is down the road, he's got his handy talkie, and I got mine, and we talk together without going through that repeater?
Are there any more check-ins? Come on.
Yeah, far down the road.
Maybe 2, 3, maybe up to 5 miles. You think? We could talk together without going through that repeater.
Is there any emergency
We could.
traffic at this
And what
time?
we
Come
do
on.
is we change it from a repeater channel on the radio to a simplex channel. Okay? And so the simplex, you're talking.
NW0SB
Radio reading.
announcements for
Okay.
tonight or tomorrow.
So Brian's talking, I listen. When he's done talking, let's go. I talk. And we can talk back and forth that way.
Oh, yeah, Jeff.
And so it's on simplex. We'll talk a little bit about repeaters tonight and how they work. And we'll get a little bit into that. So that kind of leads into where we're going tonight.
And one last call for check-in. Come on.
Are there specific frequencies that you have to use for simplex?
KE0, BEH, Kilo Echo Zero, Bravo Echo Hotel.
So I was just thinking that same thing. How do you tie it just to each other?
We'll get to them, but yes, on simplex, there's some
Jim,
frequency ranges
KE0BEH,
that
sorry
you
about
use.
this in your net. My
And,
eyes were
when
overloaded.
and there's a couple of frequencies that are known as national calling.
What's your current status? Do you have any emergency?
165, 160, 500, whatever. Randy.
Well, everybody else riding along.
520,
46, no emergency needs.
46, 520.
KE0, BEH.
That's a national calling frequency, and it's one that's known coast to coast as your national calling frequency. So you're cruising down the road, right?
Thank
You want to
Jim.
get a hold of
Appreciate
somebody,
that check-in.
and you're thinking, okay, well, I'm going to use the national calling frequency.
Last call. Come
A
on.
lot of times people, are monitoring that. So let's say we're out in the woods, right? And all of a sudden, somebody in our party breaks their leg. We need to get help. Okay, and
Hello, Kevin.
we know there's other people around that have radios, so we get on that national calling frequency and put out a distress call. People would be monitoring that. And, I drive down to the cities and every once in a while I'm hearing people monitor. People can use it besides for emergencies. You can use it I can use it to get a hold of Randy if I need to.
I got some of
As long as
that.
he's listening to it.
Most of it. Thank you, sir. Appreciate the
He's
check-in.
listening to it all the time.
Again, one last call. Come now.
Between that and doing CW. So, but anyway, I could get a hold of Randy and he'd come back to me. And then we'd start talking. And then we'd say, let's switch over to a different frequency so we don't tie it up with the national call. So it's a way to make contacts and then you move on.
Quick answer to your question, yes, you can go anywhere you want.
Back to you.
You try to avoid the duplex channels, you can literally go anywhere within your frequencies. Anything your license gives you privileges on, you can talk.
Yes.
Is there a set emergency frequency that you have?
That would be, I would go to the national calling frequency. And then in your areas, for instance, we use a repeater that we use for our emergency communication. It's one that Lee's on right now. It's 147.0.015. And we use that as our main frequency, but we also use that as our emergency frequency. So let's say we're in the middle of summer and we got a tornado coming at us, right? We got our Skywarn people out there looking for those tornadoes. They're going to be on that 147.0.015, and that's where we will run that net. And we call it an emergency communications net. And so we got people checking in, but that's what we use. And so different areas we use different frequencies, but yeah. And if you ever find yourself in an emergency and you got your radio, whoever you can hit, okay? And let's say you're in a life and death situation, and you're a technician, and you have access to an HF radio, and you do not have privileges on that HF radio in 20 meters. But if you don't get a hold of somebody, there's a good chance that your buddy's gonna die. You get on that radio and you call whoever you can call, okay? Regardless of what your license is, okay? I'm gonna tell you that, but if it's not life and death, just stay within your bounds, okay? Randy.
I don't know if anybody's watching the news on FCC citing CB operators. Anybody see those little news?
I heard something about that.
Yeah.
That's what I've been hearing.
Yep, they're running power. They're running illegal equipment, running wrong channels. You know. The FCC is starting to crack down again. So, to parrot Jeff's comment, if it's an emergency, all bets are off. If your wife's with you, she doesn't have a license, you give her the radio. She can call. The emergency situation, all bets are off.
And it's an emergency you consider. You don't have to fall into any parameters.
Yeah.
It's an emergency on your part. Start yakking.
Yeah, so, you know, I'm stuck in the mud. I'm way away from civilization, right? That's an emergency, right? You need to get search and rescue coming out there to get you out of there. You make that call. Okay? But I'm cruising down Interstate 94 and, you know, I've got my cell phone and you see an accident. What do? 911. Okay.
Slow down and look at the gore.
That would be Rick. Okay, great questions. Any other questions? I hear a question. No? Okay. All right. Well, let's see. Anybody need a brownie? I'll deliver.
Had my order already. In fact, I ate his order.
Yeah, mine is too. They'll take it.
You sure?
Peer pressure. Peer pressure.
Exactly, right?
We're
all
good.
staring
That's where the
You're
911
good.
comes in, right?
That's where the 911 comes in. Right? Okay. All right. You let me know if anybody wants a brownie, okay? I deliver within a certain zip code. Okay, so last week we talked about the metric system. Anybody remember that? We talked about these picos, nanos, millis, centis, kilos, megas, and gigas. There's a place you can buy radio equipment called Gigahertz. You'll get to know that place after a while. Right, Randy?
Oh, gosh.
Yeah, you can spend lots of money there. Mega and giga, they use capital M and G. Just remember that. Okay, and remember this, that we had 10 to the 12, or we got 12 zeros behind that 1. And 10 to the minus 12, you got 11 zeros from that one. We actually got 12. You got 1 and 4 at the top. That's Pico and Terra. Just a little review. And to get to the negative, it's 1 over the number. So 10 to the 0. 10 to the minus 1 is 1 over 10. 10 to the minus 2 is 1 over 100. It's got 2 zeros there. So kind of goes in a pattern. 1, 10 to the minus 3, there's 3 zeros.
Same thing as 1 over 10.
Okay. And we covered these practice questions. We'll have a couple of those. We'll go through them pretty quick. But milliamperes. How many milliamperes is 1.5 amperes? Anybody remember that? It is C. Yes, sir. Okay. How about this one? We got 1.5 million hertz. 1,500,000 hertz. Okay. A. I hear a B. It is A on this one.
Anything that he says with math, I'm listening.
Okay. So, which is equal to 1 kilovolt? So, that would be what? C. And 1 microvolt. Okay, so micro, we're going small, right? Yeah. If you think microscope, right? We're trying to look at really small stuff, right? So what do we think? Thinking A. Yeah, that's right. And which is equal to 500 milliwatts? B. And it is B. Yep. Milliwatts, we're going small, right? And 3,000 milliamperes. D. Okay. It is D. And 3.525 megahertz. Is B. C. It is C. And 1,000,000 microfarads. So this is gonna be 1 microfarad. And 28,400 kilohertz. Well, it won't be A, will it? It's both kilohertz. So that's A is not 4. It won't be B. It won't be B because there's not a 4 in that, right? So it's got to be either C or D. What do you think? D. Okay, and then 2425 megahertz. Now we're going to change this to gigahertz. So, what do you think? So it's not going to be D. C. That is correct. Okay. So any questions on any of those? Pretty straightforward. Kind of a brain teaser, right? Okay. So frequency. Now radio waves. How many of you guys has ever gone out to a lake or a pond and you've taken a rock and you've chucked it in? How many of you have ever done that? Yeah? I used to do that all the time as a kid, last week. And what happens? What happens when you do that?
You lose the rock.
You lose the rock. Yeah, then you have to go find it. You get wet doing that. But what happens? What do you think? So it hits there, and then what happens to the water? It ripples, kind of goes out, doesn't it? And is it all the same? That ripple? No, it's kind of changes, doesn't it? Yeah. Well, guess what? Radio waves are similar to that. So a lot of times we can think of what happens with water and what happens with radio waves to be very similar in how they react. So radio waves, they continually vary in how strong they are and how big they are, or in their strength or their amplitude, okay? You know, first let's say you throw a big rock, whoop, you get a bigger wave, don't you? Than if you threw a pebble. Not quite so much. So they vary in strength or amplitude, and they're continually changing. And so that continual change is what's known as oscillating. Okay, so you're going to hear that word oscillating. So it's talking about continual change. Now, I got draw for a minute. And you got what?
Oh, okay, well, all right. I actually made a model of two different.
She's made a wave. I was gonna draw it, but she already did. She draws better.
Well,
Much better than I do.
here's. Okay.
This is
Okay, well, that one's a smaller one.
that's what I
You want the small one. Okay.
Okay.
This is a 70 centimeter.
Okay, so this is a wave. It goes up, comes back down, and it comes back up. Okay? See how that goes like that? That's what I was going to do. Okay. So that complete up and down is what's called a cycle. Okay? Does that make sense? That whole thing's a cycle. Yeah, Clinton.
Is it 70 centimeters up and down or
No.
70 centimeters across?
It's across.
Yeah. Well, yeah, let me show it.
She's gonna get to this.
You
part.
got it upside down.
All right. It's 70 centimeters wide.
Yep.
Yeah. I mean, this is a real 70 centimeters. Yeah, so
That's top to bottom or bottom to
From side
bottom,
to
top
side.
to top?
side to
Side
side.
to side.
Side to side. I mean, this way, we call that amplitude, and that could vary according to the strength of the signal and everything, but this is what you call the frequency. The
That's
frequency, a real 70 cent, like
That's measured from the top of the
From
first
the
wave
side.
to the bottom.
from this edge to this edge, from where my,
Oh,
between
so
my
the
two
middle
fingers.
of
we see
got it.
that this is the middle. So if we have a line
Okay.
drawn right on
It-
right here, it
yeah.
goes above the line,
Okay.
then it goes below the line. And once you have complete one above and one below, that is a cycle.
This is one side, one way.
One way. And we'll talk a little bit more about this.
So that was-
But that's also what's called a cycle. Okay? Garbage man. Same time. Every night. Okay. So frequency is the number of cycles per second. Okay? So if one complete up and down series is a cycle, now if we have two of those cycles that finish in a second, that would be a frequency of 2 hertz. Okay, because there's 2 of them that finish in a second. I don't know why my throat always gets dry.
We're talking about waves.
That's probably why.
Subliminally, you wanted water.
That is probably why. Yes. Penny created a bunch of slides which are okay, so the period of the cycle is how long it lasts. Okay? How long does that cycle last? It's known as the period. So this is basically some definitions. Get some definitions, then we'll talk a little bit more about it. Now, a harmonic is a signal with a frequency that is some multiple of the fundamental frequency. So, if it has a frequency that's 2 times, or 3 times, or 4 times, it's a harmonic of its original frequency. So if we have let's say we have a 2 hertz frequency, what would some of the harmonics be of that?
4, 6, 4, 8.
4. That's the principle, right? So if I make an antenna, we'll get into this a little bit down the road, but if I have an antenna that is the length of one of these frequencies, it'll work on multiple frequencies if those are harmonics of it. Okay? So I can have an antenna that is set for 80 meters, right? And it will also work on 40 meters. Okay? It'll work on 20 meters. It'll work on 10 meters. Okay? So I can have one antenna, and it'll work on all those if it's on a harmonic of that frequency. Okay? Now, that antenna that has harmonics, will it work on something that's not a harmonic? Not without a tuner. Okay? Not without a tuner. You can get some frequencies that will work if you tune them up with a tuner. But we'll talk about how tuners come into play. But just for now, remember, harmonics, that's what you like. Okay? You like an antenna cut for the right harmonics. Okay. Here we go. This talks about it. Okay? So, one cycle is from here to here. It's going up, right? Above the line, and it's coming down here. This line represents time. Okay? Time. And this is how big your wave is, or what the amplitude is. So this is a cycle. Okay? And we can see that amplitude is on this axis, right? Time is on this one. So if we have frequency F, right? Here we got frequency F. This is 1 second. So we've got 1, up here, 2, and 3, right? So our next one is 2 times F. So this is our second harmonic. This is known as the fundamental frequency. And our next one is the second harmonic. What do we have here? Coming up, coming down. Here's 1, right? Up. Here's 2. Here's 3. Here's 4. Here's 5. Here's 6. So 6 versus, what was this one? 3 is 2 times, right? So this would be our second harmonic. Now if we want our third harmonic, we go up, down, here's 1. Okay, next time we're coming back up is 2. Next time we're coming back up is 3, 4, 5, 6, 7, 8, 9. So 3 times 3 is 9. Okay, so that's the third harmonic. Does that make sense? Yep. If I stand right in the way of you guys, I'm sorry. All right. So any questions on this, on how those harmonics work? All right. So wave vocabulary. Oh, wrong kind of vocabulary. amplitude, we see that's our strength, right? Our frequency, F is the frequency of the signal. It's in hertz, and hertz is defined as Hz, capital H, little z, cycles per second. And then we have period, which is T. And this is one cycle, and this is the time, right? Seconds. And we get, this is our fundamental frequency. And then we get our harmonics. Okay. Make sense? All right. Now we're going to throw something in here just a little bit crazy. We're going to call it phase. Okay. I go through a phase every once in a while, don't I, Rick?
Yeah, I'm always in a phase.
Well, I know you're out of phase.
You guys are werewolves.
Yeah. He might be.
Explains his arms. All that hair.
All right, so phase is used as a measure of time within the signal. So each signal of a sine wave is divided into 360 degrees of phase. Okay, so the easiest way to think of this, and this is how I think of it. Let me get out of the way so people can see. So we have this wave here. This is known as a sine wave, okay? This nice shape, okay? It's very, very pretty wave. It's very uniform, right? It's called a sine wave. Okay? Now, it goes up and it comes down. Basically, that's a half a circle, isn't it? Up and down to the same point. That's a half a circle. This is a half a circle. What happens if I take this and I flip it over here? What do I get? It's kind of an ellipse, but it's really, I call it a circle. So, how many degrees does a circle have? 360 degrees, you betcha. You betcha. So, this wave, how many degrees does this wave have? 360. Yeah, yeah. So, we think about it, from here to here is 180 degrees, right? That's 180. So, in between those, we're at 90 degrees, right? If I go halfway, I'm at 90 degrees between here and here. Now, if I go between here and 360 degrees, what do I get? 270, right? Kind of, anybody ever looked at a compass? It's in degrees, right? 360 degrees. 270 is due west. Right? 90 degrees is south, due east.
Yeah, sorry.
Clay lost.
So you're just thinking about winter.
Didn't you say you fly?
I know, that's what I think.
That's easy. Wait,
You didn't say
right, that is easy.
The airport is which direction where you're at, right?
I've been lost.
Okay, so now if we have, okay, so these two, this shows a regular sine wave, right? We have a couple of special situations here where we get out of phase. We have the fundamental, which is one with the solid line. That's our fundamental. Okay, so this is a fundamental wave. And then we have one that's out of phase. It's, you know, it's off a little bit, right? It's off. Well, this one is out of phase by 90 degrees. Because if we go from here to here, line, right? That's where we start. And this is where this one crosses the line. It's crossing the line right in the middle. This is known as 90 degree out of phase, and this is where our quarter cycle is, 90 degrees out of phase. That's case 1. Now, case 2 is just a little bit different. They both cross the axis at the same point, except this one's going up, and this one's going down. So, without looking at this, how far are we out of phase? 180 degrees, right? Just opposite. All right. Does that make sense?
Yep.
Yes, Clint.
I bet you're gonna get to this, and I'm asking the question way too early.
Never asking it too early. It's all good.
What happens if you're out of phase?
Okay. Then I turn to Randy and I go, what happens if we're out of phase?
Turn it off and reboot it?
Turn it off and reboot it.
You have to turn, you sound like an IT.
What's that?
You have to turn your license.
You're assuming I'm gonna get one. There's a lot of
There
names.
you go.
Oh, I do assume that you're gonna get it. And the math is not that bad. But yeah, you wanna be in phase, okay? You want your radio to be in phase. So sometimes you have to look at your antennas and see what's going on with your antennas. And we'll show you how to use the antenna analyzer so you can see where it is resonant, okay? So the fundamental here is a resonant antenna. Means you can use that antenna directly to your radio and it won't hurt it and you'll make contacts. But if you're out of phase, you're gonna have a hard time making contacts and it's not good for your radio.
Really, why? Receiving or transmitting?
Transmitting. You don't want to you're not gonna receive well if you're out of phase. Okay? You're gonna hear a lot of noise, it's not gonna come in clearly. But if you transmit and you're out of phase, you don't have a good match.
Does it drain more power off of your radio, or is there feedback or something? What is the result? Why is it bad for your radio, or is it just because you're not gonna make contact?
Well,
is that what it is?
it's gonna hurt the finals in your radio. There's a lot of components in that radio that can be damaged if you don't have a good match.
But it's a bow thing. How much stuff can happen?
I wouldn't worry too much about the valve fan because you can always replace that for $35. But you get some of these bigger radios. Oh. Right, Mr. Smokey?
You can do it on little ones too.
So you'll smoke the radio if you're out of phase. Okay.
Yeah.
That is the result.
That is the result. Yeah.
And that usually don't smoke.
And that's bad. You can spray it.
That's bad.
It is bad.
You smell it.
Rick has had experience.
Buy it new with a warranty.
He's on first name basis with the repair folks down at Yasu.
Can you monitor this to know, or is it something that you
Yes.
can hear?
You can monitor it.
Okay.
And one of the things that you'll learn as we go along is that whenever you set up a radio with an antenna, you want to check that antenna to make sure that it's resonant. Okay?
I suppose you just gotta read the sales coach.
Similar. I mean, we get your antenna analyzer. Jimmy here?
I see his trucks right there.
Yeah. Go have Jimmy bring his antenna analyzer in. I know he's got it.
Is this what they're talking about with the SWR ratio?
Yes, standing wave ratio. Yeah, and we're going to get into that and how we use that. But yeah, standing wave ratio shows us when we don't have a good match. Okay.
Kind of think of it as back pressure, right? The higher the SWR, the more back pressure, the less efficient, the more strain we put on the radio. So you always want it to be as clean and the match as you can get.
Now, does your tuner eliminate that, or no? Do you have to start out with a clean match?
You want as clean a match as you can get on your antenna to radio.
Okay.
But if you're off just a little bit, your radio or your tuner will help bring that in.
Okay. But if we're not resonant, like we're not multiples of 2, 3, 4 for 2.5, then you can tune that
To a point you can't.
You can tune it so the radio is not damaged, but your antenna is still operating at 2.5 efficiency.
So you're not as efficient as it would be if you had an antenna that was in resonance.
SWR just takes the pressure off the radio. It protects the components.
Yeah, and that's a key thing, to protect your components, but you want the best antenna that you can get. It's as resonant as possible so that you can make those contacts. You might be able to make some, but you'll be able to make a lot more if you're resonant.
So the antenna, you said 40 meter antenna, is that antenna 40 meters long?
It can be. Yeah. If you've got one that's 40 meters long, it should be resonant on that.
But if it was a multiple,
But you can
40,
take the
it'd be
multiples
same
and you can bring it down.
thing.
Okay, it can be a lot smaller.
So they make antennas that are mechanically produced. Yes, I did.
I say just build yourself a silo.
Dipole antenna. Those perfectly match.
Aviation makes the ACAS 128.
That's changeable on length.
Push your
from
buttons and it does everything for you.
Oh, it's vertical.
Yeah, you can have some vertical.
Project.
Mount them on your.
Yeah, there's a couple of different types of antennas. You got vertical antennas. You can run wire antennas, horizontal. We'll get into all of those in the later chapter. But yeah, those are great questions. And yeah, from now, just remember you want to be as resonant as possible. Okay. Great questions. All right. So the position within the cycle is called its phase, and phase is used to compare how sine waves signals are aligned in time, and they're measured in degrees, as we have seen here. Okay. Jimmy's going to bring in his analyzer, and we can see what an analyzer looks like. He's got a couple of them, it looks like. I knew Jim would have to. They do. So we use these to, what do we use them for, Jim? Why don't you explain what these are and what we use them for? These are little tools that we can use to check the inductance and capacitance of our antennas. And what do you what are the readings are for our antennas match going into the radio. So 50 ohm match. And it allows us to tune the antennas so that they coordinate back and forth real good with getting the most signal out and not dropping off with reflective power or any of the other discrepancies that happen in building an antenna. So I'll let you take a look from here. Okay, thank you, sir. So in essence, we use these to, we'll take and we'll put the antenna on here, fed by a coax, okay? Put it on the end of here, and we're able to turn this on, and we're able to see how this antenna is functioning. I haven't turned it on because we don't have a coax for it, right? But we can see if that antenna has a good match, if it's got a good SWR. We can see how the coax cable is. If we've got a problem with the coax cable that we're running, we got a break in it, right? Oh, we got a problem. This will help us to diagnose what that problem is, okay? So whenever we go out into the field to run our radios, Jim always brings all of this. I bring a couple, and between all of us, we probably have half a dozen or more antenna analyzers.
Was the work on handheld? Or is it not as important on handheld?
It would not.
This one would not, because it depends on what frequency it will go to. Now, this one here actually would. It'll go up to UHF, VHF frequencies. Okay, this little one, right? You can get these that will. Lee's got one, but they're very expensive to do that. So what I do the same thing that Jim does here. I have one like this that I use mainly for high frequency antennas. And I have one of these that I use that if I'm working with UHF, VHF, I'll use this one in order to test it. And so, different tools. I don't want to lose Jim's batteries. Lost that case on it. So, don't want to lose his battery. But anyway, these are some of the tools that we use. And this one costs about $80, something like that. This one is more along the lines of 300 or 400, 400 on the 230. I've got one that goes to 50, which goes down to 10 meters, or goes down to 6 meters. And I think I paid two. I paid some. She saw the bill. Rick got his free. So anyway, these are good tools that can be used. All right. So, in what we've talked about, do you want to catch that light right there? By you? Thank you, sir. Or Lee, one of you. Okay. So what is the unit of frequency from what we talked about? Okay, it hertz. The way I always remember this is hertz rental car. The frequency of me going hertz rental car and getting a rental car is very low. Okay, what describes the number of times per second that an alternating current makes a complete cycle? What was that? Okay, frequency. That is correct. Yes, excellent. Okay, what is the abbreviation for megahertz? What do you think?
I throw C out there.
Okay, I heard Ryan with D. Okay, so if we remember from that other slide, M is always, the mega is always capitalized, right? And so is hertz. Okay, so hertz is always capitalized as well. So two capitals with a little z is D. What's the abbreviation for kilohertz? Now, D. I think Lauren got it. I think so. D, yeah. Right.
Whoa, you're losing me here.
Okay. Kilo has a small k. Yep. Hertz has the big H and a little z. Okay. Make sense?
It does. Now that I'm looking at this.
Okay. Very good. Okay. Now we're going to talk a little bit about where some of this stuff fits in that I've been kind of throwing out there. And I've been throwing out there VHF, UHF, HF. Well, what does all that mean? What does all that mean? So we have a whole spectrum of frequencies. Okay. Down here at 3 kilohertz. And on this we go up to 300 gigahertz. That's a big spectrum, isn't it? It's quite wide, quite wide. Well, when we get down below 30 kilohertz, we get into what is known as the audio range. So if you have a wave sitting down there under 30 kilohertz, guess what? You can hear it, okay? You can hear that. And as we were driving down here tonight, Penny was talking about that. She has a demonstration that we'll show later, where she was getting some audio frequencies by using the piano. And I think she made a recording of that, didn't she? Yeah. I'm jumping into your stuff, and I
Okay.
apologize, but that's good stuff.
Got pictures?
Just hearing.
Well, I guess I could talk about it too.
Yeah. Okay. Once we get through this slide, we kind of get it. Okay. So the audio is down here in the very low frequency. Okay. Then we get above 30 kilohertz. We're not going to be able to hear it with our ears. But guess what? Radios can. And this is where the radio frequencies begin. Begins at 30 kilohertz. And it comes all the way up. And you get this. This is our radio frequencies. All the way up here. Well, within this, you got breakdowns, right? From 30 to 300 kilohertz is our low frequency. From 300 kilohertz to 3 megahertz. So this would be 3, how many zeros? Megahertz is a million, right? So you would have 6 zeros out here, right? Why do you think we don't write 6 zeros out there? It gets a little big. So we use megahertz. And from 3 megahertz to 30 megahertz is high frequency. Okay? Then we get above 30 megahertz all the way up to 300 megahertz, and it becomes our very high frequency, or VHF. You ever heard of VHF? VHF. And then we get up to above 300, up to 3 gigahertz. It comes up to the UHF, which is the ultra high frequency. VHF is very high frequency. And then we get from 3 gigahertz up to 30 gigahertz, and we get up to super high frequency. And 30 gigahertz to 300 gigahertz is the ELF high frequency. Extra high frequency. Okay? So within that radio spectrum, we have all kinds of things that operate. Okay? Who's ever heard of AM radio? Okay. Yeah, I still got one of those in the car. It still does AM. For now, we're talking about getting rid of that. You heard that controversy? Yeah. Pulling out of cars. Used to be the only thing you could get was AM radio back in the day. Yep. And very staticky, right? And so then we get into the high frequency. That's where our shortwave radio comes in. Okay. Then we get into the VHF, TV. You got TV in that VHF area. VHF TV. That's the stuff where you got an antenna up on top of the roof, right? And back in the day, yeah, it used to be channel 4, 5, and 9, 2 and then to tell you how old I was, they only had VHF TV back in that day, and the TV was black and white. Believe that? Black and white, no color, no color. I'm not exaggerating.
There was one.
There wasn't when I first started watching TV.
People had
Like when
children
you
just so
were
they
like-
didn't have to change their channels.
Oh, yeah. That's exactly right. I was the remote control.
And the antenna.
Don't change the channel, Jeffy. I was the remote control. But anyway, we had VHF TV. Then we thought it was great when channel 50 came along, and it was UHF. And we could get another channel on the television set. And that's when color came. Yeah, we had color. Lucille Ball wasn't just black and white. Probably don't even know who Lucille Ball is.
I do.
It makes us older, yeah. Right?
You have to hook me up with that, what do you
Yes,
call that
Clint.
group?
So are you allowed to transmit on VLF?
Very low frequency?
Yeah.
Now that's a good question.
Because submarines use that.
Well,
So
So BLF, which would be
3 to 30.
3 to 30 kilohertz. And we start out at 135 kilohertz, which is 2,200 meters.
that's in the low frequency.
And that's in the low frequency. So we do have some privileges here in low frequency, but not down in the VLF.
VLF is what the whales use.
Yeah.
And that's one you got submarines use.
So anyway, this chart will become very valuable. Did everybody get one? I know we were running low on them last week. I got more. I had more come in. So anybody that didn't get one, let me know. I got them. So that's why we have these charts. So, but yeah, we wouldn't operate down in the VLF. We're not going to operate a lot in LF, to be honest with you. That antenna is going to be mighty long to operate down in that.
You have to get a permit.
So, mainly we're running from the middle here up to here. Okay. Now our mobile phones operate up in the UHF area as well. So we're really operating here in this area. Okay. Make sense? Any questions? Yes.
So the rolling out of like 4G and 5G internet, has that impacted and radio out?
One of the things that the FCC does is they allocate out the frequencies. And they say, okay, AT&T, Verizon, you guys have this part of the band, this part of the radio spectrum. And ham radio, you guys have this part of the radio spectrum. U.S. Air Force, you get this part of the spectrum. So they allocate out different parts of the spectrum to different services, okay? Amateur radio, as we talked about, is a service, right? A radio service. So so it gets allocated out. Now, occasionally, when the FCC starts allocating out frequencies, it can start to infringe upon the ham bands. There's a, I don't know if it's what the FCC is trying to allocate out some frequencies right now that's going to impact VHF, I think. Is it VHF, Randy? And it's right at the edge. It's right at the edge of the VHF band. Well, what did we talk about? Being, I don't know, we talked about it much yet, but as we get close to the edge of that band, there's a possibility that we might have too much power. We might go over the edge, right? Well, guess what? They might come over the other way. And who is it they're trying to give that to? I don't either. Ricky, you remember?
Thanks.
It might be. they're trying to allocate right to the edge of the band to another group. Well, what's going to happen when they start broadcasting at the edge of that band? It's going to come into the ham band, right? And that's going to take away part of where we can operate.
The problem we always fight with allocation of frequencies is that most of these companies that want them are huge, huge companies. They have lots of money, and they will spend whatever it takes to get access to these frequencies. We have a large political organization that supports amateur radio called the American Radio Relay League, and they're fighting all the time to maintain the privileges that we have. Anytime we have a set of privileges right now that we don't use a lot, they look at that and say, well, you guys aren't using that. We can reallocate that, make some money. So it's really so very important when you get your license, get on it, talk on these bands. Make everybody know that, yes, that radio is live as well, we'll use them. It's a never-ending battle with the FCC to keep what we have.
Yeah, because the FCC will charge these big companies, AT&T, T-Mobile, Dish Network, all these people that use the airways, right? They charge them, so they're bringing a lot of money into the coffers, right? And if they can charge more money by giving away some of the hand bands, they're going to do that. So that's just a great question. Other questions? All right. Okay, so signals that have frequency greater than 20 hertz to 20,000 hertz or 20 kilohertz are radio frequency or RF signals. Okay. Now, when we get below 30, it's an AF or audio frequency signal. Okay. Just a couple more slides and then we're going to take a little break, okay? So electromagnetic waves. Anybody heard of electromagnetic wave? Yeah? What do you think it's made up of? What do you think?
Electros, magnets, and waves. Magnetic forces.
Magnetic forces and electricity, right? So it's made up of electric and magnetic energy. Okay? So the electric and magnetic fields vary in pattern of a sine wave. Sine wave that we looked at, right? They vary with that, in the same pattern. And electromagnetic waves travel at the speed of light. Boy, those guys are pretty quick.
Is that the same as EMP?
Yes.
Yeah.
Every time we broadcast, it's carried to the
Okay, so it's cruising at the speed of light. I have tried to race the speed of light and I've never won. I've tried to race the speed of Rick. He's never won.
But I beat the speed of light.
He dreams well. He dreams well. Okay. So it's pretty fast, right? So moving electrons in an antenna take the place of the moving magnet. So you got electrons. Boy, these are little fast little buggers, right? These electrons, they're just cruising. And they take the place of the magnet. And a signal from a transmitter can make the electrons in an antenna move, transferring the energy from the signal to electromagnetic waves that travel at the speed of light. Yes, correct. Do not think of it. If we had those electromagnetic waves traveled at the speed of Rick,
they'd be electromagnetic rips.
they'd be electromagnetic ricks, and we would not we'd be still waiting for, what was the dude? Mark Macaroni? No, screw it. Marconi. I knew it was something like that. We'd be still waiting for his first signal from his radio to travel. Okay. Then the same process works backwards too. So you're sending a signal out at the speed of light. You're getting a signal back at the speed of light. Okay? So, excellent, excellent. All right. And electromagnetic waves encountering an antenna makes its electrons move in sync with the wave. So we got this wave, right? We got the sine wave. And these electromagnetic waves are using that same pattern, okay, as they go out from your antenna. All right, electromagnetic energy is transferred from the wave to the electrons. So we get this energy, it's created by what? Electricity and magnetism. Is transferred from the wave out to these little electrons, and the moving electrons create a signal that can be detected by a transceiver, by your radio. Okay. So, if you think about those little handhelds that we had last week, they're getting signals that are coming at the speed of light. They're catching those. Well, they're catching pretty good. Better than my hand will. It's a good thing I have a radio. Okay. So the electromagnetic spectrum is divided into ranges of frequencies in which these waves, these electromagnetic waves, they have similar characteristics and they behave in a similar fashion. So we, just like this chart, okay, just like we see how we got low frequency, very low frequency, medium frequency, high frequency. So that's, this electromagnetic spectrum is divided up just like that. And each range or segment has a different name. And the waves with a certain range of frequencies which can be used for communication are called radio waves. Okay? So as we see on that chart, there's a section that goes where the radio is, from here all the way up. Right? That's what they're talking about here. So the radio spectrum is that range of radio signal frequencies that we see there. That's the radio spectrum. Starts at 20 kilohertz and continues all through several hundred gigahertz. It's way up there. And then it's this specific range of frequencies in which the signals are used for a common purpose or have similar characteristics are called a band. Okay? So if you think about it, who's a group that you like to listen to? Music class. Britney Spears.
Flying Dutchman.
Okay, 10th Avenue North. It's a band, right? They have similar interests, don't they? Okay, so they play the similar kind of music, right? So I bet they play different music than Johnny Cash. Yeah, I would think so. Johnny Cash had a band. Guess what? He would be on one end of the spectrum, and 10th Avenue North, they would be on the other end of the spectrum, right? Well, the same thing is true of the radio bands. And you're going to hear them called bands more often than not. You're going to have a 20-meter band. You're going to have a 10-meter band. You're going to have a 40-meter band. Okay? They have similar characteristics, and they're usually within a certain range of frequencies that are very close to each other. Okay? And they behave very much like each other. Now, the 80-meter band, which is a very low band, okay, it has a lot of noise in it. Okay? And when I say a lot of noise, you're going to hear a lot of static. Okay? A lot of static. But you can hear people on it, right, Randy? But the 80 meter band versus the 20 meter band, how's the 20 meter band compared to the 80 meter band?
Much quieter.
Much quieter. It behaves differently, doesn't it?
It goes a lot farther.
And it goes a lot farther. The frequencies within that 20 meter band, they act a lot like each other, right? The frequencies in the 80 meter band, they act a lot like each other. Okay? That's because they are next to each other, but that's how it gets broken up, so that they're different frequencies. It's much easier to remember that's the 20 meter band, or that's the 10 meter band, rather than that's frequency 14.075. It's in the 20 meter band. We'll show you how that works, but it's kind of easier to remember that it's in the 20 meter band. So they have similar frequencies, and frequencies used by amateurs are called the amateur bands or the ham bands. So those are the frequencies that we use. Okay, we use the ham bands or the amateur bands. What's that?
I said I was in an amateur band.
I got you. Okay, and frequencies above 1 gigahertz are generally considered to be microwaves. Just like your oven. Just like your microwave oven. Okay, so these are the spectrum ranges, okay? Very low frequencies, 3 kilohertz to 30 kilohertz. Low frequency, 30 kilohertz to 300. Just as we talked about, extremely high frequencies are 30 gigahertz to 300 gigahertz. So we usually operate for the amateur radio bands right through this area right here. Make sense? We'll catch you. Good one. All right. We're going to take a brain break right about now. Or let's take 5 minutes. Just kind of get up, stretch, breathe in.
Anyway, but just think of that like a map, okay? That represents 600 million. Okay, that's one right there.
So it's good for one of the 30 points around the two.
This wave would be wave 1 per the actual speed of light, 200 million years is actually approximately, and the actual speed of light, 299,792,458 or 100.
Is your antenna that 10 meter, or are you still leaning over?
So yeah, I mean, you can see how the whole thing is.
You're gonna
Okay,
take it
so
out.
now I just want to
Are you gonna get on the mosquito net on down here? Live that far from me, I live closer than I do.
Okay, now this one, how many ways do you do?
We come down here. I don't bother it. But the frequency is measured over the distance of 300,000, 300 million. In the whole here. That's always the same.
That is
You
always.
gotta be that alpha down when you.
So yeah, remember that. 1 second, and the
I
frequency.
did have trouble last week with that guy who was in the mud.
So 1 hertz
That's
is
the
1
first one.
wave.
Actually, been a hard time here.
You know, it's 2 waves, and how many of them are 2 waves right here? Yeah, well, it's truly not very hard when you know, yeah, so expert, how many ways are there? Yeah, 16 or, I mean, I just doubled it. But so, you know, so it's probably created a way. So you know that the higher the frequency, the smaller the wavelength. That's just why I created this thing, it's just so you can see that, because people get confused about that. Yeah, so this is a higher frequency, you know, how small these waves are, you know, how big these are. Yeah, so when you have big waves, you have small waves, when you have high frequency, you have small waves. Because, you know, it's all has to fit frequency. Waves you try to fit in and all of it. Yeah. So here's the big question. And what I just found out, I have some questions on it. So what is the relationship between wavelength and frequency? Yeah, it is 300 millimeters, which is what's the approximate velocity of the radio wave? Okay. And then I'll do on okay. A meter is approximately. So sometimes it might be helpful to yard on the regular and hertz, because there's certain things for people. You don't need thousands, what a person is only $4. That doesn't seem to really French fries and medium fries, small cake. You go to the burger on Mondays and get a burger combo. Normally, if you get that particular meal, so to get out of it, especially when it's nice, the burger, orange burger and fries. So the wavelength, how big is that wave? Remember, the bigger the wave, you go shopping at Costco and go so this is like 300 millimeters. How many 6-meter waves will fit?
I seen that Superman guy last week. Looks like a Bronco or a Ford or something.
field the whole front seat. Yeah, he's big. Well, when we come to San Luis, if I usually pick the modest, and he's wrecking more system, they get two in big pieces, throw it on a sandwich and throw it in the frosty. So, yeah, it's a good one, so, tables.
So this is actually 2 meters, like a little bit more than 2 yards. Okay, so, and then I think we have imagine how many,
Yeah, he was sitting in that parking lot.
that is the
Talking about very clean, driving outside in the park. I guess that's where, Tom Shaw.
So sometimes it's kind of like I mean, the real map is
Yeah, he has a front plate.
by, and the only way to that is 2 meters, that is a 2 meter weight, that is a diagram of what a 2 meter weight might look like. That's what it's. So, yeah.
Are you gonna use that for Jeff's birthday present? Jump out of the way.
That is his birthday present. That's taken.
You got a 2 meter weight in there, 2 meters?
Now, if you know,
He's an intelligent guy.
okay, you were talking about that, emergency frequency.
Yes, we will probably call it 146.520.
Okay, so if you want to get the exact wavelength of that, you do divided by whatever, you can get how big that wavelength is. So with this system, I use 5 meters.
Or she had that big glory.
So you can have a.
Opened it up and she had a liberty suit. And she hadn't put that in back to him. Yeah, she'd be out there on 15, Oh, that Slater boy got in trouble because he.
So are boys always the same height?
Oh, no, the height, that would be the amplitude, and that would could vary, that has to do with the strength of the wing. It's just kind of like with sound, like in pitch, like I can sing it softer or I can sing it louder, and the frequency is the same, but the amplitude loudness depends on, yeah. So, yes, the amplitude can vary, but the frequency, that has to do with how many waves. Okay, so to simplify the computations, since frequencies are normally referred to in megahertz, a megahertz is a million high, and the speed of light is also in millions of megahertz. We can drop to millions and just divide 300 by the frequency or wavelength. And the wavelength. I should have been in megahertz and frequencies. Okay. But anyway, so, you know, instead of saying 300 million, we just say 300. We say 50 megahertz instead of 50 million. 6 meters. Or 300 divided by 6 meters equals 50
Standing
megahertz.
like a mugshot.
So this calculation is.
If you didn't need it for
Well, it's something you use all the time, and then when you're, you know, figuring out how to make your antenna, you go back to
Yeah, I
that
didn't have,
300
mine even right now, mine, I don't have.
300 million. Yeah, to do that, yeah, okay. So what is the formula for converting frequency to approximate wavelength in hours? So just,
I took my motorcycle license, that guy says, yeah, read them lines, I tried, he says, yeah, he said, forget it, it won't be long, it'll be
yes. Because remember, you always, it's always 300 divided by. Wavelength in meters equals 300 divided by frequency.
I took mine, I was in the first class in April, and he takes.
And always remember this, 300.
They know it.
750. Oh, is that on the side of 90?
Oh, okay, all right, right.
Motorcycle size?
Okay, so radio waves have been identified by wavelength or frequency. I know last year when it's changed that, you know, I have to learn 2 names for for
Cause
so
the guy
long.
that had the
We're just
ninety
trying to
come over
make
go up so many.
That actually,
Back years ago, they did.
wavelength refers to a range of frequencies
Oh, it wasn't one of
that is known as a band. Like, the 6-meter band has a range of 50 to 54 megahertz.
Or gold ring.
300 divided by 6 equals 50.
They
So
do that damn
50
figure
is
eight
actually
ring, that was a-
inside that range, but it does not.
Then I
So
thought
the
it funked
frequency
it
range
went
will
around the
sometimes
building
be
there,
a
you know,
little
in
bit
town
above
where it
or
was.
below.
I went around that building, I come back. and
For
I
instance, the
had
2-meter band
didn't
has
have
a
it down,
range of
just waiting over
144
here, so I went over to where everybody is, I thought I flunked
which is
it,
a little
but they
below
didn't
the
have my-
computer frequency.
Then you start
It's like
belling.
300 divided by 2.
So
So sometimes this
and
happens,
smoke
but
that tire out.
when it does, it's
You
always
did a
really
good
close,
job, but
like,
you didn't need to excel in it.
that's really
So what the hell you did? I said, I thought I talked to them, sitting there pointing and hollering at me.
so sometimes it will be included, sometimes it'll be a little below.
Right in balance?
Still passing, you know.
Okay, so in addition to frequency, which of the following is used to identify temperature?
It's still not cash.
I was gonna say.
Well,
Then
for,
the text this morning and asked him, he sent me back up there tonight, which now it says, oh, check with our treasurer and see what happens. I get checks from people, I don't cash them. But I'm like,
Okay, which frequency is in the 6-meter amateur
no, it's the
band?
brain.
Remember I just talked about what that
oh,
was?
yeah,
It
you
was
should laugh.
50 to 54 megahertz. Okay, so which one of those is in the
He sees me coming, he starts sweating, he shakes his
Yes.
head, I don't know why.
71 now, traffic.
Okay, which amateur band includes
Do.
146.5?
That's funny that